Statistic is on our life, and of course, your life could be counted on the statistic. Like this for an example. Statistic, if I may say, is everywhere. Everywhere we go, business, medical, science, social, you will always facing what we call statistic. In business and economic, you will see the information of prices, quantity produced, quantities demand. As a businessman, you can see how many consumers that buy your product. As a trader or investor, you really can see how S and B interact in the curve of a stock. In medical, you will see the patient data from ages, genders, health issues that they had before, what they eat, what they probably shouldn't eat, what medicine that they had before, and why they should have this medicine. In social, you can see how many people that participated in election, how much demonstration that occurs in a period, why this man became president and why this woman didn't. In science, you can calculate how many plants that will cover the entire forest in a year of growth. You can calculate how high the airplane can reach by its average. You can calculate the number of chemicals that should be mixed in the bottle of magic. So, by that, we can conclude that statistics is everywhere and it used on every field of study. Science, social, medical, sport, music, art, and especially in business and economics. But the question is, why should we study statistics?
The first reason is that numerical information is everywhere. The second reason for taking a statistics course is that statistical techniques are used to make decisions that affect our daily lives. That is, they affect our personal welfare. Example, the Environmental Protection Agency is interested in the water quality of Lake Erie, as well as other lakes. They periodically take water samples to establish the level of contamination and maintain the level of quality. A third reason for taking a statistics course is that the knowledge of statistical methods will help you understand how decisions are made and give you a better understanding of how they affect you. No matter what line of work you select, you will find yourself faced with decisions where an understanding of data analysis is helpful.
How do we find the word statistics? We encounter it frequently in our everyday language. It really has two meanings. In the more common usage, statistics refers to numerical information. Examples include the average starting salary of college graduates, the number of deaths due to alcoholism last year, the change in the Dow Jones Industrial Average from yesterday to today, and the number of home runs hit by the Chicago Cubs during the 2010 season. In these examples, statistics are a value or a percentage. Other examples include: first, the typical automobile in the United States travels 11,099 miles per year. The typical bus, 9,353 miles per year. And the typical truck, 13,942 miles per year. In Canada, the corresponding information is 10,371 miles for automobiles, 19,823 miles for buses, and 7,001 miles for trucks. Second, the mean time waiting for technical support is 17 minutes. And the third, the mean length of the business cycle since 1945 is 61 months. The above are all examples of statistics. A collection of numerical information is called statistics, or plural. We frequently present statistical information in a graphical form. A graph is often useful for capturing reader attention and to portray a large amount of information. For example, chart 1.1 shows Frito-Lay volume and the market share for the major snack and potato chip categories in the supermarkets in the United States. It requires only a quick glance to discover there were nearly 800 million pounds of potato chips sold, and that Frito-Lay sold 64% of that total. Also note that Frito-Lay has 82% of the corn chip market. The subject of statistics, as we will explore, has a much broader meaning than just collecting and publishing numerical information. We define statistics as the science of collecting, organizing, presenting, analyzing, and interpreting data to assist in making more effective decisions.
Types of statistic. The study of statistics is usually divided into two categories: descriptive statistics and inferential statistics. What is the difference between descriptive and inferential statistics? Descriptive statistics are procedures used to organize and summarize data. Inferential statistics involve taking a sample from a population and making estimates about a population based on the sample result. First, a population is an entire set of individuals or objects of interest or the measurements obtained from all individuals or objects of interest. And the second, a sample is a part of the population.
There are two types of variables. A qualitative variable, which is non-numeric. Usually, we are interested in the number of the percent of the observation in each category. Qualitative data are usually summarized in graphs and bar charts. There are two types of quantitative variables, and they are usually reported numerically. Discrete variables can assume only certain values, and there are usually gaps between values. A continuous variable can assume any value within a specific range. There are four levels of measurement. The first one is with the nominal level. The data are sorted into categories with no particular order to the categories. The second is the ordinal level of measurement presumes that one classification is ranked higher than another. The interval level of measurement has the ranking characteristic of the ordinal level of measurement plus the characteristic that the distance between values is constant size. And the last one is the ratio level of measurement has all the characteristic of the interval level. Plus, there is a 0 point and the ratio of two values is meaningful.
In the first chapter, we have learned about basic theory about statistics and what they are used for. In short, statistics is a branch of mathematics that is used to compile, analyze, and describe data in an interesting way so that the data can be seen and understood clearly. In daily life, we often see many types of charts and graphs that maybe you are still confused about what they are used for. If you have ever been to an election venue to see the results, surely the election results will be shown in the form of charts or graph like this. This means that statistics can be found in everyday life, especially in the world of work. Well, in this second chapter, we will discuss what a statistical table or frequency table is and the types of frequency tables.
2.2 Constructing a frequency table. Frequency table is a grouping of qualitative data into mutually exclusive classes showing the number of observations in each class. For example, we can see at the table 2 to 1. The total number of cars sold last month was 180 cars from 4 different locations, which is Kane, Olean, Sheffield, and Tionesta. The most common graphic form to present a qualitative variable, like the example above, is a bar chart. In most cases, the horizontal axis shows the variable of interest. Bar chart is a graph that shows qualitative classes on the horizontal axis and the class frequencies on the vertical axis. The class frequencies are proportional to the heights of the bars. Another type of chart that is useful for depicting qualitative information is a pie chart. A pie chart is a chart that shows the proportion or percentage represented by each class of the total number of frequencies. For example, we can look at the table 2 to 3, 2009 Ohio State's lottery expenses. To present it in a pie chart, we have to find the percentage of sales, which is a requirement for making a pie chart. There are 4 classes that will form the pie chart. We can see it at the chart 2 to 2. Because each slice of the pie represents the relative share of each component, we can easily compare them. First, the largest expense of the Ohio Lottery is for prizes. Second, about 30% of the proceeds is transferred to education. And the third, operating expenses account for only 5% of the proceeds.
Graphic presentation of a frequency distribution. A histogram from a frequency distribution based on quantitative data is similar to the bar chart showing the distribution of qualitative data. The classes are marked on the horizontal axis and the class frequencies on the vertical axis. The class frequencies are represented by the heights of the bars. Histogram is a graph in which the classes are marked on the horizontal axis and the class frequencies on the vertical axis. The class frequencies are represented by the heights of the bars, and the bars are down adjacent to each other. Example, below is the frequency distribution of the profits on vehicle sales last month at the Applewood Auto Group. The question is, construct a histogram. What observation can you reach based on the information presented in the histogram? The class frequencies are scaled along the vertical axis or y-axis, and either the class limits or the class midpoints along the horizontal axis. To illustrate the construction of the histogram, the first 3 classes are shown in chart 2.3.
A frequency polygon also shows the shape of a distribution and is similar to a histogram. It consists of line segments connecting the points formed by the intersections of the class midpoints and the class frequencies. For the example,